Now the next problem they're going to work now, this shows you, sort of how to calculate some statistics when you have other statistics. It also is the first problem we work where they ask us for confidence intervals, which we'll talk about while we're working this problem. Now the problem reads as follows. It says, assuming that the rates of return associated with a given asset investment are normally distributed, that the expected return is 18.9% and that the coefficient of variation is 0.75, answer the following questions. A part, find the standard deviation of returns. B part, calculate the range of expected return outcomes associated with the following probabilities of occurrence: 68, 95, and 99. Now those are the typical confidence intervals that are asked for. The C part, they ask you to draw something. I'm not going to ask you to draw anything, but we're going to do parts A and B of this problem here. Now, in this particular problem now, they give us the coefficient of variation, and they give us the expected return, the mean of the distribution. And then they ask us, what's the standard deviation? Now, to calculate the standard deviation, to work this problem, you have to understand that all of these things exist in the definition of coefficient of variation, which is your risk per unit of expected return. So the coefficient of variation is the mean or expected value of the distribution divided by the standard deviation. They gave us the coefficient of variation as 0.75. They told us the expected value, the expected return was 18.9. And so we're going to solve this equation for standard deviation. So 18.9 times 0.75, that gives us 14.175 as the standard deviation for this asset. And that's the A part of this problem. In the B part now, we're going to talk about confidence intervals. Now there are three common confidence intervals. There's 68% confidence interval, 95%, and 99%. Now, to calculate a 68% confidence interval, it's simply the mean plus or minus one standard deviation. Okay, so for this particular asset, the mean is 18.9, and we're going to add and subtract from that one standard deviation, which is 14.175. So if we take the mean, 18.9, and subtract 14.175, that leaves us with 4.725. To get the other end of the confidence interval now, it's going to be the mean plus one standard deviation. So in this case, 18.9 plus 14.175, and that gives us the upward side of the confidence interval is 33.075. Now, what you would say about this if you were talking to a boss or a client, and you're trying to show them, explain to them that there's no guarantees in life, that asking you for one number, given what's called a point estimate of return, there's virtually a 100% chance that you'd be wrong if you did that statistically. So what you tell your boss is that, well, we're 68% confident that the return on this asset will be somewhere between 4.75% and 33.075%. Now again, that sounds sort of strange to a boss or a client, so you should be ready for that. But that's how you explain a confidence interval. In industry, this is the common confidence interval that's used. In academics, we use 95 and 99%. And if you get to the 99% confidence interval, it's sort of like saying, well, I expect the value to be somewhere between negative infinity and positive infinity. It's kind of an odd thing to hear. But to calculate the 95% confidence interval, it would be the mean, 18.9%, plus or minus two standard deviations. So if you took 18.9 and added to it 14.175 times 2, then you would get 47.25. And if you took the mean and subtracted from it 14.175 times 2, you get a negative 9.45. For the 99% confidence interval, it's the mean plus or minus 3 standard deviations. So if you take 18.9 minus 14.175 times 3, you get a negative 23.60%. If you take the mean, 18.9, add to it 14.175 times 3, you're going to get 61.425%. And again, 99% confidence interval. You'd be 99% confident that the return in the next time period is going to be somewhere between what? A negative 23.6% and a positive 61.425%.